Hello students, my name is Nariman Mali. I am from Baku. Today I am going to talk about IB Math HL, Paper 1, Section A. On the screen you can see my mobile and email, so any questions are welcomed. Let's start. So this is about paper 2018, so very fresh math paper. Section A, question 1. So we are given two vectors and we should find cosine theta angle between them, cosine of angle. So let's call one vector A, another B. Then components of vector A will be 3, minus 4, minus 5, so it is A1, A2, A3. Components of vector B will be B1, B2, B3, it is 5, minus 4, and 3. So signs are important. Equation for cosine is product of vectors divided by their modules. Products of vectors, dot product, we have formula, and for modules we have formulas. So we substitute components and we care about square root of 50, so it is 2 times, this is why we take 50 out of square root, so we get 1650. Question done. Question 2. Sketch the graphs of two functions. So let's look at first function, y equals x over 2 plus 1. So I use the straight line, so I need 2 points. I use intercept, so I take when x is 0, y is 1, so this is 1 intercept, and when y is 0, x is 2. So I take 1 point, another point, and draw straight lines through these points. First graph is ready. Second graph is absolute value of x minus 2. So let's find when it is equal to 0. So x minus 2 equals 0, so it is at x equal 2. So first we draw for x more than 2, we draw x minus 2. So x minus 2, again y equals x minus 2, x is 0, y minus 2, y is 0, x is 2. So I draw again straight lines through these two intercepts, and now at point 2, when x is less than 2, I have negative part. So this negative part, because of absolute value, should go up, so I reflect it, and as a result we have line of symmetry. So we have two graphs ready, and we notice that they intersect at 2.1 at x a bit less than 1, another at x about 6. Second question, we should find algebraically solution when these two functions are equal. So solution to this equation. Absolute value. By definition, absolute value is minus a when a less than is negative, and a when a is positive. Here a is x minus 2. So we consider two situations. So a is less than 0. So x minus 2 less than 0. So we should write x minus 2 as minus x minus 2, and it will be more than 0. We substitute this expression instead of absolute value, multiply by 2 to get rid of fraction, then we open brackets and we rearrange x's on one side, numbers on another side, and solution is 2/3. Now when a is more than 0, x minus 2 is 0, so it is simple. Now x minus 2 is positive, we rewrite it as x minus 2, substitute it into the formula, and in the same way we get answer 6. So we got two solutions. Question is done. Question 3 is about probability. So we have x can have 5 values, 0, 1, 2, 3, and 4. Probabilities are different. A, we should find the value of p. What do we know? We know that total probability equals 1. So we add up all probabilities, and here p and minus p is simplified, cross out. We got p cubed equals 0, 1, 2, 5. We use calculator, we get p equals 0.5. Done. DI, find expected value. So expected value, by definition, is sum of probability by the times value. So we multiply all values by probabilities, add up, and knowing the value of p, we find that it is 1,375. Double I, we should find probabilities that x is more than mu. More than mu is more than 1,375. So it is 2, 3, and 4. So we add up these three probability, substitute the value of p, and we get 0.5. Question is done. Next question. Question 4. Consider the curve, find the coordinates of the points of the curve where the gradient is 0. So gradient is derivative, so we should find derivative. The problem here, we should turn fraction into exponent form and use chain rule. So y to the nth power, if we have, then we should put n, y n minus 1, and find derivative dy dx. So here, the first term, minus 1 goes in front of minus 1, and derivative of 1 minus x is minus 1. Second term is the same story. We have coefficient 4, but derivative of x minus 4 is positive, so we don't have minus 1. So we equate this derivative to 0. We have equation. Now we write it in fraction form, cross multiply. To solve this equation, we should square both sides, but don't forget to have two channels when they are equal and when you put minus. So plus channel. Squares are equal. x1 equals to minus channel, so we put minus in front of one of the squares. Answer is minus 2. So question is done. Question 5. We're given geometric sequence, and we should consider sequence element of which are based on the geometric sequence. Show that the new sequence is arithmetic sequence. State the common difference in terms of R. So by definition, if we have arithmetic sequence, the difference of two subsequent elements should be equal to constant. Let's check. So I write difference of two neighbor elements, substitute the expression that is given, use the property of logarithm difference, and I get constant value. It is logarithm with base 2 and power r in module. So this is common difference. I call it D. A particular geometric sequence has first element 3 and sum of infinity of 4. Find the value of D. So we have formula for sum to infinity for first element and ratio r. So we find r, it is 0.25. Now we substitute this r into the formula for common difference because we should calculate it. And here, to use calculator, we change base to 10. So base was 2, now it is 10. This is why we divide by old base with 10. We use calculator and we get minus 2. Lesson is done. Question is done, sorry. Right, question 6. Consider two functions. They are product of a minus x times sine x and times cosine x. We should find derivative of each. We use product rule. Here the product rule is written, so UV are two functions, and plus we should use chain rule. Don't forget to differentiate finally. Here should be G by F. Okay. So let's consider the first function. So e minus x sine x, first derivative of first term, then second term, then first term derivative of second term. To find derivative of e minus x, so it is e minus x plus times derivative of minus x, which is minus 1. Sine derivative is cosine, so we have simple formula. The same story is with second function. Hence, or otherwise, find definite integral. Here we have two ways: straightforward way and let's say smart way, because here we have hence. So B, using integration by parts 2 times, having as u exponent minus x and as v cosine x, we are getting integral that we need equals u, this is v derivative, which is cosine minus cosine, then we use the same integration by parts for this integral, and finally we have on the left we have one integral, and here we have the same integral but with plus or minus sign, so we can be moved to the left, and we have 2 times interesting integral, the sum we divide. Smart way. So if we add derivatives of this function f and g, we will get minus 2 functions that we should integrate. So we integrate both sides, and we have f plus g divided by minus 2. This is expression for integral of interest. So question is done. Don't forget that it is definite integral, so you have to find value at point P and subtract value at point A. So this is the result. Question is done. Question 7 is about two complex numbers. It is straightforward question. So in A we should find real part of this ratio. So we substitute the values, and the standard way is we should get rid of imaginary part in the denominator. So to do that, we multiply both sides, numerator and denominator, by conjugate. Conjugate is just minus, appears here, minus. As a result, we have plus and minus, so it is square difference of squares, and I squared give us minus 1, minus give us plus, so we get expression, very simple expression for denominator. And numerator, we just again have difference of squares, and we keep it as it is. In B, they ask us the real part of this expression. So we have this expression, and they say that the absolute value of z equals absolute value of w, which means a squared plus b squared equals c squared plus d squared. I take off the square root, which is when you square you get this expression. So as a result, the numerator becomes 0, so real part is 0. By the way, here when we were finding the numerator, we ignored imaginary part because we need real part. Question 8, integration. A, U-substitution suggested substitution to find this indefinite integral. So first of all, we should substitute not only x but also dx. To do that, we use this expression and find and differentiate it with respect to x, both sides. On the left we get du dx, on the right we get 1 over 2 x, 1 over 2 minus 1. Then we instead of x square root of x, we substitute u. Simplifying, we get 2u du equals dx. So we substitute this expression for dx, and we get the following formula. And here we see u squared plus 1, which is arctangens. So we have returned to x, so we get 2 times arctangens square root of x. They ask us to express answer in terms of arctan q, so this is why we don't use calculator, but we use so we should find this definite integral. So we have to evaluate it at 1, at 9, and find the difference. So we get arctan 3 minus arctan. So let's call one angle A, another B. Then we get tangent A minus B, tangent of difference, and here instead of tangent A we can put 3, instead of tangent B we can put 1, so we put these values and we get 1 over 2 and return again to A minus B. A minus B is arctangent half. This question is done. This is section B. Section B will be next time. Thank you for your time. Please, if you have question, send me this question by email or call me. Goodbye.